Hello there and welcome to A-Level Further Maths. Here we're looking at integrating with partial fractions so we can answer questions from exercise 3E. So just a reminder of how to do those partial fractions questions before we get started on integrating them. When you've got a simple partial fraction like this, you've seen how to deal with these in A-Level Maths. What we're looking to do here is split this fraction up into its parts, partial fractions. So we're looking to split it up into two separate fractions, a over 2x plus 3 and b over x plus 2, and work out what a and b need to be. You've done a lot of work on partial fractions, so this is not a video to go through how to do partial fractions, but the answer is 7 over 2x plus 3 over x plus 2. You're very welcome to now pause the video and see if you can turn the left hand side into the right hand side. It won't take a lot of brain power to turn the right hand side into the left hand side. That's not the question. The question is, if you were to integrate this thing on the left hand side, then you would first turn it into the thing on the right hand side and then do the integration by Lunds. Another one might involve just 3 fractions in case you'll split it up into 3 different components, each with an a, b or a c on the top. A next example might have a bracket where it's repeated. It's a repeated bracket, so x plus 3 squared. The way we deal with these is that you put one number on the x plus 3 without any powers on it, and then add another term on top of x plus 3 squared. So if that was a cubed, you'd have one fraction with just one power of x plus 3, one fraction with 2 powers of x plus 3, and one fraction with the third power of x plus 3 on it. So you do all of the powers going up to that power. So if you had 6, you'd have 6 fractions, one with each different power going up to 6 on it. The answer to that is this one here. Sometimes you'll get the same power on the top as you will on the bottom. So what you'll see here is we've got an x squared on the top here, and in the case on the denominator, we'd also have an x squared. So what you'd need to think there is, okay, so on the top I've got 2x squared, on the bottom I've got x squared, and if I was to cancel those two out, not doing the whole thing, but you'd get a constant term. So in this algebraic fraction, you need to have a constant term at the front and then plus 2 coefficients with your fractions on the denominators. In this case, it was 2 as the coefficient of a, and that is a good general method that you could use for working out what the 2 is. Work out what the x squared divided by the x squared is, and then whatever your coefficient is, that's the value that will be your constant. If your power on the numerator is bigger than the power on your denominator, then you need to consider doing 5x cubed over x squared, which is what you'd have if you expand the denominator, and then you would get 5x. So it's going to be something times x, and then you use every power down from that value of x. So if it was a 4 on the top here, it would be x squared plus something x plus something. If it was a power of 7 on the top here, you'd do x to the 7 divided by x to the 2. That would leave you with x to the 5, and you'd put on your other side some constant times x to the 5 plus some constant x to the 4 plus some constant x to the 3, all the way down to just a bog standard constant, and then 2 components because you've got 2 factors on your denominator. So you've got sometimes constant term at the front of a partial fractions and then your 2 partial fractions. And you probably will have recognised the majority of this from A-level maths, and there's an extra bit more for further maths when you get something like this term on your denominator, x squared plus 1. So you'd split it up into 2 different partial fractions, but on the second partial fraction where you've got x squared plus 1 on your denominator, you need to go 1 power less and then all the coefficients times that power of x down from there. So for example, if this 2 wasn't a 2, it maybe would have been a 3. So if it was a 3 here, then you'd have x cubed plus 1 on the denominator there, because that's what will match up your denominator on the left hand side, but then you would need a bx squared because you start with 1 less than the power on the denominator, and then you go down from there, 1 and then a power of 0 on your constant term d there. So this is a little extra bit for further maths when you're dealing with these kinds of partial fractions. Split it into its parts first, obviously, but then with your numerator needs to contain every power of x down from the 1 less than the power of x on the bottom, just like we see here. And that kind of works for the first bit as well. If your power of x on the bottom is 1, then you go 1 less than that, which is 0, which is just the constant terms. The rules still apply there. And before I wrote on top of it, let's just erase that, you can see here that it would have been 4x plus 3. Maybe you might want to pause the video and just make sure that you can turn the left-hand side into the right-hand side. Okay, let's go through 2 questions in this video that will aim to see how we use partial fractions in questions and then what we need to do with the integration afterwards. So in the first one, we're going to first of all split 1 plus x over x cubed plus 9x into partial fractions. So we need to split it up into the denominator up into its factors first. So it's going to be x and then x squared plus 9. So in this question, it's going to have x on the bottom of one fraction, x squared plus 9 on the bottom of another fraction. On the first fraction, it will just have a constant term on the top, but on the second fraction, it will have some multiple of x plus c. So what we're now going to do is we're now going to equate this thing on the left-hand side with this thing on the right-hand side, and we'll multiply both sides by x bracket x squared plus 9, just that it's now all in one straight line. Now what you've probably learnt to do with A-level partial fractions is to just start substituting in numbers for x that will helpfully let you work out what a, b and c are. Another way of doing it is to compare coefficients. So what I've done first is I've expanded the brackets, grouped together my x squared terms, that will be ax squared and bx squared, so it's a plus bx squared, the x terms which will just be cx, and the constant term which will just be 9a. The next thing I'll do is I'll start to compare coefficients with the left-hand side and the right-hand side. My coefficients are going to be looking at what's in front of x squared, x, and just the single coefficient. So the first easy one I can compare is that the x term on both sides should match up and be equal to each other. So 1x should equal cx. Now what that means is that on the x coefficient, c equals 1. That's to say that what the number is in front of x on both sides is 1 on the left and c on the right. So c equals 1. I could now do the constant term. So what's the constant on the left? That's just 1. What's the constant on the right? That's 9a. So I know now that 9a should equal 1, and therefore a should equal 1 over 9. And the final more difficult term will be the x squared term, in which case a plus b will equal nothing, because there's no x squared term on the left-hand side, so a plus b should equal nothing. In which case, if you look at what a is down here, then b should be minus 1/9. So your partial fractions are 1 over 9x, because that was the curve, that was a, and we're matching it up with what we set it, the a, b and c equal to up here. And then b will be minus 1/9, so it'll be minus 1/9 x plus c, which was 1 over x squared plus 9. And what you might want to do on the second fraction here is just times top and bottom by 9, and you'll get 9 minus x, because you have to times the 1 by 9, this thing by 9, both the things on the bottom by 9, and you'll get this thing here, 9 minus x over 9x squared plus 81. Okay, so now we need to know how to integrate this expression here. Well, the first thing I'm going to do is I'm going to split it up into 3 different integrals. The first one, that's obvious, that's 1 over 9x, and then the numerator can get split up as long as I use the same term on the denominators. Then I'll just do a bit of factorising to make my integrals a bit easier. The first one is going to be factorising out the 1 over 9, so that will move to the front, and now I've just got the integral of 1 over x. On the second term, it's just going to be cancelling out the 9's on the top and the bottom to leave me just with 1 over x squared plus 9. And then the third term I'll factorise out 1 over 9 to leave me just with x over x squared plus 9. And now I'll integrate all three functions separately. The first one is going to be just by a ln integral. The differential of the bottom is the top, so that's just 1 over 9 ln x. The second expression, that's going to be a arctan integral from the formula booklet, and in this case a will match up with 3 because a squared matches up with 9, so it's going to be 1 over 3 arctan x over 3. And then the last expression will be again a ln type integral. If I differentiate the bottom I get 2x, but I can't just create a 2 out of thin air. I'll need to divide by 2 at the front, so it's going to be 1 over 18 at the front of this integral. So it's going to be 1 over 18 ln of the denominator x squared plus 9 plus c. So there we are, that's the answer for this question. It's a pretty long one. 1 over 9 ln x plus a third arctan x over 3 minus 1 over 18 ln x squared plus 9 plus c. Okay, let's move on to the second question then. So again, we're going to start by splitting it up into partial fractions. I've noticed on the denominator it can actually factorise into x squared plus 3 x squared plus 2. That's a key part for this question. So now I'm going to be splitting it up into its partial fractions. The first thing I notice is that if I divide the highest power on the top by the highest power on the bottom, I get 1. So what will actually happen here is that I should get a constant term of 1 at the front here, but I don't quite know that. It doesn't always work, so I'll just put a as the constant term at the front, because the top power is equal to the bottom power. That means I need a constant term on the other side in the partial fractions. And then the two partial fractions I'm going to have is x squared plus 3 and x squared plus 2. But on the top of both of those, it needs to go up to a power of x and then down from there on the powers of x. So it's bx plus c and dx plus e on those numerators. So lots of constant terms to work out. To work those out, I'll multiply both sides by the denominator, x squared plus 3, x squared plus 2. And I'll get this big long string of algebra here. On the left hand side it will cancel out both of those denominators and I'll be left with just x to the 4 plus x. On the right hand side it will be a times this denominator, so that will be both of the factors. On the second term it will cancel out the x squared plus 3, so I'll just be left with the x squared plus 2, and on the right hand expression it will be cancelling out the x squared plus 2 to leave me just with x squared plus 3 as the multiplication. Now if I expand the brackets and group everything together, I'll be left with ax to the 4, a bx cubed and a dx cubed, so I could factorise that to b plus d x cubed. If I factorise out the x squareds, I'm going to get 5ax squared, cx squared and ex squared, so that can simplify to 5a plus c plus e x squared. On the x term it will be 2bx plus 3dx, which will factorise to 2b plus 3d lots of x, and then the constant term will be 6a plus 2c plus 3e. So the next thing I'll do is I'll compare coefficients, and the coefficients I'll be comparing are x to the 4, x cubed, x squared, x and 1, and that will give me 5 equations. That's great because I want to solve 5 equations and work out what 5 coefficients are. So the first one will be 1 times x to the 4 will equal a times x to the 4. So 1 should equal a. So that's a nice easy one to get the ball rolling. The x cubed term will just be b plus d, but there's nothing on the left hand side on the x cubed term. So it will just be b plus d will equal nothing or 0. On the right, on the next one will be 5a plus c plus e, and there's no x squareds on the left, so that x squared term should equal 0 or nothing. On the x term, I have 1 on the left hand side. I have one of those x's, and I've got 2b plus 3d on the right hand side, so that should equal 1 there. And the final one, I don't have any constant term on the left hand side. I have 6a plus 2c plus 3e on the right hand side, and that will be now what I've done here, actually you can see 5a, because I know that a is 1, when I've written it in the equation, I've just written it as 5 and as 6. That's because I know that a is equal to 1. So as soon as I know some easy ones, I'll use those numbers later on in my equations. Because what I've now got is just 4 equations with 4 unknowns to work out. I'm not going to show you how to work out equations. All I'm going to tell you is that the answers are a equals 1, b equals -1, c equals -9, d equals 1, and e equals 4. So that my partial fractions are this thing here. It will be 1 plus minus x plus minus 9 over x squared plus 3 plus x plus 4 over x squared plus 2. Right, so that's a lot of work. We're only halfway there. We've done the partial fractions part. I'm just going to rewrite it as this partial fraction here, factorising the negatives out to the front of the fraction with the denominator x squared plus 3. And now let's get to the part where I have to integrate. In this case, I'm going to split it up into 5 separate integrals. One with a 1 dx, one with an x over x squared plus 2 dx, 4 over x squared plus 2, then it's going to be minus x over x squared plus 3, and minus 9 over x squared plus 3. The first one will just be x, because we integrate 1, you get x. On the second one, it's a Ln integral, so when you differentiate the bottom, you get 2x. So I'm going to put a 2 at the front there. Can't just put 2's at the front without balancing the half to the front. So I'm going to get half Ln x squared plus 2. The next term will be an arctan integral. I want to factorise the 4 to the front, and then a is going to correspond to root 2. So it's going to be 4 over root 2 arctan x over root 2. The fourth integral is going to be another Ln integral. The differential of the bottom will be 2x, but I can't just create a 2 out of thin air. I need to balance it out with a half at the front. So it's going to be minus a half Ln x squared plus 3. Rather, that's a little typo there. And the final one will be another arctan integral, which will give us minus 9 over root 3 arctan x over root 3, because the a squared matches up with the 3. And then we can see what we're simplifying here. Right, well, I've got 2 Lns that could be simplified, because when you subtract 2 Lns, you do the division inside the Ln brackets. And that's all I'm going to do to simplify. It'll be x squared plus 2 over x squared plus 3 inside the Ln bracket, because there's a subtraction on one of them and an addition on the other. And then I'm just going to simplify the surds on the arctans, and then that will be the final answer for this question. So these questions are very, very long. They do give you lots of marks for them, and it's really important you're accurate as you go through these questions. So I'm going to give you one question to have a go at independently, and then I'll go through it afterwards. Have a go at question 4 from page 72, exercise 3E. Right, okay, let's have a go at this question then. So the first thing we're going to do is split into partial fractions. So 2 minus x over x cubed plus 4x. The first thing I'll do is I'll notice that I've got a factor of x on the denominator, and then it will be bx plus c over x squared plus 4. So the next thing I'll do is I'll times by x cubed plus 4x, and that will give me 2 minus x equals a bracket x squared plus 4 plus bx plus c multiplied by x. Now what I'll do is I'll expand the brackets on the right hand side, and it's going to be a plus b that will be in front of x squared. It will be the c that will be in front of x, and it will just be 4a as the constant term, and that will equal 2 minus x. So I'll start comparing coefficients now. So the coefficients, I'll choose the easy ones to do first. I can see that the x coefficient, c will equal minus 1. That's the coefficient on the x. The coefficient on the constant term will give me 2 equals 4a, so therefore a must equal a half. And the last one to do will be the x squared one. So I'm going to do a plus b equals, there's no x squared term on the left, so that will equal 0. So therefore b will equal minus a half. So my integral is going to be the integral of a, which is 1 over 2x, plus b, which is minus a half x minus 1 over x squared plus 4 dx. So when it comes to my integration, I'll probably factorise out the minus half to the front, and then that will turn the 1 into a 2. So my integral is now going to be 1/2 integral of 1 over x plus the integral of, I'm going to factorise out the minus half to the front, so it'll be minus 1/2 x plus 2 over x squared plus 4 dx. And let's now split that right-hand integral up further. So it'd be minus a half integral of x over x squared plus 4 dx minus a half integral 2 over x squared plus 4 dx. Right, so now is time to do the integration. The integral of 1 over x is ln x minus the integral of this middle thing here. Well, it's going to be a ln type integral, because if I differentiate the bottom I get 2x, but I can't just create a 2 out of nowhere. I'll divide by the 2 at the front, and I already had a half, so I've now got a quarter. So it's going to be a quarter ln x squared plus 4, and then it will be minus, I'll factorise out that half and that 2 will cancel each other out. And now it's going to be an arctan integral where a squared matches up with 4, so it's going to be a equals 2, so it would be a half arctan, and then it would be x over 2 plus c. And there we are. We could probably simplify this a little bit more. If I factorise out a quarter, it would be ln x squared over x squared plus 4, because if I turn that into a 4, then I can move power of a half, so power of 2 inside the bracket. It's just a basic application of laws of logs, really. And then it'd be minus half arctan x over 2 plus c. And lovely, there we are. That's the answer to this question from page 72, exercise 3e. Hopefully you found this video helpful. Yes, the questions are long. Yes, they're going to be boring to go through if you're good at partial fractions, and if you can do arctan and ln integrals, then they are pretty difficult. But it's good to go through them. Make sure your work is methodic. Make sure you're setting yourself up for a good structure when you come to do an exam question. And then when you've got that good structure in place, you can focus on the minutiae detail to make sure you don't make silly, incorrect mistakes. Okay, so make sure you've answered all the problem-solving questions, the exam-style questions from exercise 3e, and hopefully you found this video helpful. Thanks very much for watching.